Hey class, today we're going to be talking about percents, taxes, and inflation. Remember all that time that you spent saying in high school how you wish the math class talked about stuff that was applicable to real life? Well, that's today. First, let's talk about percents. The word percent means per hundred. To convert a percent to a decimal, you simply divide by 100. To write a decimal as a percent, multiply that decimal by 100. And then put the percent sign to the side, of course. Finally, to write a fraction as a decimal, divide the numerator by the denominator. For example, 17% equals 17 out of 100, which equals 0.17. 3/8 equals 0.375, which equals 37.5%. And 0.5 equals 50%, which equals 1/2. A percent can be used to explain a change in quantity. So let's look at an example. If I have a budget of $200 a month, and in the first week, I was really stressed, so I bought $150 of Oreos. What percent of my food budget have I already spent on Oreos? Well, let's look at dollars used over dollars total. That's 150 divided by $200. That's 0.75 or 75%. So I've already used 75% of my food budget just on Oreos. I really like Oreos. In conclusion, I need to eat less Oreos. Now let's look at change. An important concept is the percent of change equation. This is percent of change equals new amount minus the base amount, all divided by the base amount. Remember this equation because it's going to be incredibly important. In other words, we see how much our amount changed and then divide it by the original amount. One business application of this equation is to calculate the markup of an item where the base amount is how much it costs to make the item and the new price it is selling for, i.e., percent of markup equals selling price minus dealer cost over dealer cost. Now let's look at another example. Back in olden days, it cost just $5 for a foot-long Subway sandwich. Now it costs $6. What is the percent change in the cost of a foot-long over this time? Well, the solution, we look back at that equation, new amount minus base amount, all divided by the base amount. That's $6 minus $5, all divided by $5. That's 6 minus 5 is 1, so $1 divided by $5 is 0.2 or 20%. Thus, we had a 20% change in the cost of a footlong. So now let's look at the percent equation. Everything for the rest of this section will just be an application of this one equation called the percent equation. This equation is percent times base equals amount. Note from the last example that we got the percent was 20%. 0.2 times $5 equals $1, where $1 is how much the price of a footlong has increased. That increase is also called the markup. We can also rearrange our percent equation, if need be, through algebra as percent equals amount over base and base equals amount over percent. So let's look at another example. This section's very example heavy. If I play 200 matches of Super Smash Bros., but only win 13 of those matches because I am really bad at video games, what percent of the matches did I win? Well, let's use our percent times base equals amount equation. So we have percent times 200 equals 13, and we're going to rearrange that like we just did to be percent equals 13 over 200. That's 0.065 as a decimal, and that's 6.5%. So I won 6.5% of the matches. So I probably shouldn't start playing Super Smash Bros. Competitively. Now, let's look at taxes. And yes, even taxes are just an application of that wonderful equation we just learned. So, I named this section Taxes Tech, because I'm funny. So being able to file your taxes properly is actually just an application of the percent equation. For example, if Nicolas Cage has had a bad year of acting and only made $58,375, then the IRS says he falls in a tax bracket such that he must pay $5,183.75 plus an extra 25% of what he made over $37,650. So how much did he pay in taxes? Well, let's find out. So, 5,183.75 plus our percent, which was 0.25, times base, which was 58,375 minus 37,650 equals 5183.75 plus 0.25 times 16,070, which equals 9,201.25. That's how much he paid in taxes. Now let's look at inflation. Inflation is a rise in the level of prices of goods and services over a period of time. Usually, inflation is measured by the Consumer Price Index, where the base is 100. For example, if right now the CPI is 237 in comparison to 1984, then that means prices are now, on average, supposed to be 237% of what they were in 1984. If college tuition in the year 1984 was just $971, wow, that's so cheap, and college tuition is now a whopping $9,410, did college increase in price reasonably in comparison to inflation? Solution: percent times base equals amount. Percent times 971 equals 9410. Percent 9410 over 971 equals 9.69, which is 969%. Since 969% is 3 times the CPI, we see that the cost of college has increased over 3 times what it should have for inflation. So no, college price has not raised at a reasonable amount. And yeah, we should probably be upset about that. And that's it for today.